Hello, everyone. Welcome to Cyber in Practice, Episode 11. I'm Nginx, and today I'll be demonstrating containerization security architecture. We'll cover the fundamentals of containerization, review its security benefits, and then deploy multiple Docker containers in a live demonstration. What is containerization? Containerization packages an application and its dependencies into a portable container that runs constantly across environments. Unlike virtual machines, containers share the host operating system kernel, making them lightweight, efficient, and easy to deploy. Understanding what containers are is important, but equally important is understanding why organizations have adopted them so rapidly. Why containerization matters. Organizations use containers to deploy applications faster, improve scalability, and reduce resource consumption. From a security perspective, containers also provide workload isolation, helping separate applications running on the same host. To fully appreciate those benefits, it helps to compare containers to the technology many organizations used before containerizations became mainstream. Containers versus virtual machines. The key difference is that virtual machines require their own operating systems, while containers share the host operating system kernel. This allows containers to start faster, use fewer resources, and scale much more efficiently. With that architecture difference in mind, let's review a few technical concepts you'll see during today's demonstration. During today's demonstration, you'll see Docker images, containers, port mapping, application isolation, and scalability. These concepts work together to make containerized applications efficient and easy to manage. Now that we've covered the terminology, let's establish exactly what we'll accomplish during the hands-on portion of the presentation. Our objectives are simple. Deploy 2 web server containers, verify they're running independently, demonstrate scalability, then clean up the environment. With our objectives in place, let's take a quick look at the environment we'll be working in. We'll be working in Kali Linux virtual machine using Docker and Nginx. The goal is to deploy multiple web servers from a single image and observe how containers operate independently on the same host. Now that we reviewed the environment and objectives, let's move into the live demonstration and see containerization in action. I'm navigating to the project directory that contains the files and resources for today's demonstration. Before we deploy anything, let's first see what images are already available on the system. Here we can see the Docker images available on the system. Images serve as a reusable template used to create containers. Today, we'll be using an Nginx image to deploy our web servers. With Nginx image available, we're ready to deploy our first container. This command creates our first container named Web1. The port mapping forwards traffic from port 8080 on the host to port 80 inside the container where Nginx is running. Now that our first container is running successfully, let's demonstrate how quickly additional workloads can be deployed. Now I'm deploying a second container from the same image. Notice that it runs independently while using a different port mapping. With both containers deployed, let's confirm they're running properly. Both containers are now running. This confirms that Docker has successfully deployed 2 independent workloads on the same host. Now let's verify functionality from the user's perspective. Let's verify the first container. The default Nginx page loads successfully, confirming that the container is serving web content. The first container is operational. Let's verify the second one. The second container is also operational and running independently from the first. Both web servers are accessible, but accessibility alone isn't the goal. Let's verify that both workloads remain independent. Both containers remain active. This demonstrates workload isolation, where multiple applications can operate separately while sharing the same host system. Having demonstrated containers deployment and isolation, let's move on into the cleanup phase. Now we'll stop both containers as part of the container lifecycle management process. The containers have been stopped. Next, we'll remove the containers. We're removing the containers while keeping the original image available for future deployments. Finally, let's verify that the environment has been successfully cleaned. This confirms the containers have been removed and the environment has been cleaned up successfully. Now that the demonstration is complete, let's step back and review the overall workflow we followed. What we just completed is a standard container workflow. Start with an image, create a container, verify operation, demonstrate scalability, then clean up the environment. Whether an organization deploys 2 containers or thousands, the process follows the same basic lifestyle. Before we conclude, let's review the most important concepts demonstrated today. Today, we saw how containerization package applications in the lightweight, isolated environments and can be deployed quickly and efficiently. We demonstrated scalability by launching multiple containers from a single image and observed how container isolation supports operational reliability. While containers provide many advantages, organizations must still focus on image security, configuration management, and runtime monitoring to maintain secure environments. Containerization has become a foundational technology in modern clouds, DevOps, and cybersecurity environments because it allows organizations to deploy applications quickly, efficiently, and securely while maintaining workload isolation and operational flexibility.
Thank you for watching Cyber in Practice. If you enjoyed this demonstration, stay tuned for future Cyber in Practice episodes.